Hi guys, and welcome to this video. First of all, I will start by presenting myself. So my name is Sebastian Helmut. I am embedded system architect that has been working for over 15 years in embedded system domains. I have worked on big semiconductors companies like Qualcomm, Broadcom, and ST Microelectronics. And right now I am part of Wadex Technologies. Wadex Technologies is an online platform-based company that is aiming to provide full online courses covering different embedded system topics, ranging from processor architectures like ARM and RISC-V to some of the embedded system advanced topics. Within this YouTube channel, I will try to present some set of videos covering the different embedded system topics. In today's video, I will try to present the major differences between thread and handler modes within an ARM Cortex-M microprocessor. ARM Cortex-M microprocessor is well known by their power efficiencies and small memory footprint, making them very suitable for microcontroller-based devices. Any ARM Cortex-M based microprocessor does support two modes, thread mode and handler mode. After boot up, or to be more precise, after power on reset sequence, the ARM Cortex-M microprocessor will boot on thread mode. So your reset handler, which is your first function to be executed by your program after reset, will execute in thread mode. Then, to be able to jump to handler mode, we need to trigger an exception or an interrupt. So any exception or interrupt handler will execute by default in handler mode, and your main application will execute in thread mode. Now, after we jump into our exception or interrupt handler, the process will be executed in handler mode. And to return to thread mode, we need to return actually from our interrupt or exception. Now, there are two, let's say, privilege levels supported by thread mode. So the thread mode can execute in privilege or unprivileged access level. By default, after boot up, the CPU will execute in thread privilege, as you can see here. After we jump to our exception or interrupt handler and execute in handler mode, the CPU can return either to thread mode privilege or thread mode unprivileged. Here there is certain bit basically within the control register that control basically if our thread mode will execute in privileged or unprivileged access level. However, from application point of view, after we return from the first jump to our exception interrupt handler, we must return to thread unprivileged level. So this is in general the flow of our application executed on ARM Cortex-M microprocessor. So guys, as you can see here, there are two modes supported by our ARM Cortex-M microprocessor. There is handler mode and thread mode. Handler mode will be executed always in privileged access level. However, thread mode can execute in privileged or unprivileged access level. The only way to switch back and forth between thread mode and handler mode is via exception or interrupt entry-exit routine. If we want to switch from thread mode to handler mode, then we need to take an exception or interrupt. If we want to switch back from handler mode to thread mode, then we need to return or exit this exception or interrupt routine. The same thing in terms of switching back and forth between thread mode and handler mode is applicable for both thread privilege or thread unprivileged. Thread unprivileged is not supported by the Cortex-M0, M1, and is optional in M0+. Means it is supported actually within the M3, M4, M7, M33, and so on. Now to switch from thread privilege to thread unprivileged, we need to manipulate certain bit within this control register. Control register is an ARM Cortex-M special register, and there is certain bit is called unprivileged bit. That one, if it is set to 1, then the CPU will execute in thread unprivileged. Now there are two ways actually to switch to this state, thread unprivileged. If we have been already running on handler mode, then we need to manipulate basically this unprivileged bit while running in our exception or interrupt handler. And then once we return, we'll have basically this bit number 0, which is this unprivileged bit set to 1. And it gets set basically within the handler mode, and hence we will run on thread unprivileged. The other way, if we have been already running on thread privilege, we can then access the control register. The control register is a special register and is accessible mainly while running in privilege level. Hence, if we have been running already in privilege thread mode, then we can access this control register. Then we set this bit number 0, which is the unprivileged bit, to 1, and hence the CPU will be able to run on thread unprivileged. Now, in terms of supported features, the different modes within an ARM Cortex-M does support two sets of features. First of all, or the first set of features is the privileged access levels, and the second set of features is the bucket stack pointer registers. In terms of privileged access levels, the handler mode will execute always in privilege level. Privilege level means basically the CPU will have access to the different CPU special registers, as well as the special hardware block registers like the MPU registers. However, when running on thread mode, we can execute either in privileged or unprivileged access level. To execute in privileged or unprivileged, this depends actually from the bit number 0 of this special register called control register. If the bit number 0 is this in privileged bit is cleared, then the CPU will execute in thread privileged. If this bit is set to 1, then the CPU will execute in thread unprivileged access level. The second set of features supported by the different modes within an ARM Cortex-M microprocessor is those bucket stack pointer registers. The CPU in general have a single stack pointer. However, the stack pointer can be pointing to what is called main stack pointer or process stack pointer. Hence, our Cortex-M microprocessor has the support of two bucket stack pointer registers, the main stack pointer or the process stack pointer. When running in handler mode, the ARM Cortex-M microprocessor will be using always the main stack pointer. However, when running on thread mode, the CPU can execute, or let's say use, the main stack pointer as well as the process stack pointer. There are two ways actually so that the CPU can use the main stack pointer or the process stack pointer. The first way to select whether the CPU use the main stack pointer or process stack pointer is as well via this control registers. There is this bit number 1. If it is cleared, then the CPU running on thread mode will be using the main stack pointer. If it is set to 1, then the CPU will be using the process stack pointer. The second way is via the mechanism to return from the handler mode to thread mode. There is what is called XReturn value. This is a magic value used when returning actually from exception or interrupt routine to thread mode. There are certain bits within this magic value. If it gets manipulated properly, then we can select either the main stack pointer to be used while returning to the thread mode or the process stack pointer. Now I am having this Keil project that will be executed on an STM32 503 RP microcontroller. This platform is using a Cortex-M33 microprocessor, and that one obviously does support two modes, the handler mode and thread mode, and the thread mode does support as well the privileged and unprivileged access levels. This Keil project consists of a startup code to boot our device, and the first function to be executed is this reset ISR function. This one actually, after doing some pre-initialization, will jump to our main function, and this one will jump basically to the specified example number. In our case, will be example number 1. The example number 1 consists of main function, which is this example underscore 01, and this one is configuring the first interrupt line, which is our window watchdog interrupt, to trigger this interrupt and jump to this default handler. The main goal of this project is to demonstrate basically how our CPU will boot on thread privilege access level, and then how we can switch from the thread mode to handler mode. And as we will see later on that on handler mode will be executing in privilege and will be using the main stack pointer, and how on thread mode actually we can either use the process stack pointer or the main stack pointer based on the control register value. I will be loading basically the compiled project into the flash memory. Then I will start this debug session. As you can see, now I am in main function, so the system already booted. So first of all, we need to basically to see the internal state of our CPU. So as you can see, here we are in thread mode, privilege. So the CPU, after power on reset, will boot on thread mode and will have this privileged access level. The stack pointer by default to be used is this main stack pointer. So we need to have those 3 nodes. After power on reset, the CPU will execute in thread mode, will have the privileged access level, and will be using this main stack pointer. Now, if we jump to our example, here we are configuring this first interrupt line, which is the window watchdog timer. So here I will be triggering basically our interrupt, and I will be jumping basically to this default handler. Now we need to keep an eye basically on the internal state of our CPU. So we trigger basically this interrupt line, and here we go. So the CPU switches from thread mode to handler mode. However, the privilege level has been kept to privilege, and the stack pointer has been kept to the main stack pointer. By default, when running on handler mode, the CPU will be always on privilege and will be always using the main stack pointer. So there is no way actually to change those 2 parameters. Now we're gonna return basically from our interrupt to the main program. As you can see, there are certain instructions to be executed. And then we'll be jumping back from our interrupt or exception to the main program. So here we are doing a branch with exchange to the link register, and this link register will have this magic value, which is called this X return. With this X return, actually, we can manipulate whether we're gonna use the main stack pointer or the process stack pointer when returning from the interrupt or exception to the main program. So this is a way basically to switch or to select which stack pointer to be used while running on thread mode. The second way is via the control register. We're gonna see this later. So here we're gonna return, and once we returned, as you can see, the CPU returned back to thread mode. Here we didn't manipulate basically the privilege of the thread mode, so we're gonna use the privilege, access level, and the main stack pointer as well. So we didn't manipulate basically those parameters. Now, one easy way basically to manipulate those parameters is via the control register. Now we are running on thread privilege. Privilege means basically we'll have access to the different hardware blocks, including MPU register as well as the special registers like control register. So we can just try to access the control register and try to manipulate the bit number 0 and bit number 1. Here we'll have basically these 2 bits, nprev and spcell. nprev means if we set it to 1, the CPU will run on thread unprivileged. And this is what happened, as you can see. So we switch it from thread privileged to thread unprivileged by setting basically this bit number 0. Now the stack pointer in use right now is the MSP, as you can see. If we set this spcell to 1, here we go, we switch it to use the PSP. Now the CPU, of course, has single stack pointer, so it will be either pointing basically to the PSP or MSP. So the MSP is already initialized, however the PSP was not initialized. So once we trigger the switch or the selection to be using basically the PSP register, then the SP has been loaded with the value of 0 because our PSP actually initially was not initialized. However, this confirms basically that via the control register, we can switch the privileged access level for our thread mode, as well as we can select either the main stack pointer or the PSP or process stack pointer to be used while running on thread mode.